Hello, everyone, and welcome back to the Counterpoint Podcast. I'm your host, Maurice, and today we're going to be talking about AI, and specifically generative AI. Joining me today on the podcast, I have Associate Director Mohit Agrawal, based in Amsterdam, and Akshara Bassi, based out of India. Hey, Mohit, how's it going?
Good. How are you?
I'm doing good as well. And hello, Akshara. I hope you're doing well as well.
Yeah, I'm doing awesome. Thanks for asking.
Perfect. So let's get right into it. Generative AI has been a very hot topic over the last few months. And at MWC or Mobile World Congress, Qualcomm, for example, showcased an on-device generative AI solution called Stable Fusion that can generate an image offline based on text input. Another example of this has been Adobe's generative fill in Photoshop, which can essentially generate or replace a background based on the image that you're working on. And another example is Google, which has its own generative AI model. And there are many other companies as well that are focusing on this really hot trend. But why is this such a hot topic? Since last year, basically, everybody was talking about the metaverse, and now seemingly the focus has really shifted to this generative AI, and specifically since the launch of ChatGPT. So my first question actually goes to you, Akshara. What can you tell us about generative AI?
So, generative AI is type of artificial intelligence under the umbrella of artificial intelligence that can create new content, including text, images, audio, videos. So, it's how does it work is it learn the models work by training on existing data, and then they use that new data that the model has learned to generate new examples which are in similar to the original data that they have trained upon. So generative AI is focusing on creating new content, while traditional AI, which we have seen over the past few years, have been more on analyzing data and making predictions, but not generating new content per se. So how do they work is the models are trained on big data sets and they require large compute power. Usually they are trained on in data centers, and then those models can be used for a variety of applications, from a smaller smartphone level applications to large enterprise level applications. So as you just mentioned, ChatGPT is one of the most famous examples right now that we had of generative AI, which can hold a contextual conversation and is basically it's trained on a lot of parameters. About the newer one is approximately trained on 180 billion parameters, and it can generate text, code, audio, video, and images, and which is almost undistinguishable right now from human written text.
I see. That's all very fascinating and a lot to comprehend, but I want to bring in Mohit into this conversation as well. Akshar mentioned a little bit about ChatGPT already. Can you tell us a little bit more about any differences between ChatGPT and generative AI?
Thanks, Maurice. For most people, generative AI and GPT are the same thing. And that's probably because the term generative AI became popular when ChatGPT was launched. In reality, generative AI, though, and GPT are both types of AI, but and then they can be used to create new content. However, there are some key differences between the two. So, generative AI is a broader category of AI techniques that involve generating new content based on patterns learned during existing data. The content could either be text, image, video, music, or code. On the other hand, GPT or generative pre-trained transformer is a specific type of generative AI model based on transformer architecture developed by OpenAI. And this is used only for generating content around text and code. And I must also add, it is one of the most powerful and versatile generative AI available today.
You know, there has been a lot of interest now in ChatGPT and generative AI and all these big language models that are being used. But there's also an issue about bias in there in the data sets, right? Is there anything you'd like to add about that has been going around?
Yeah, you brought a very important challenge around the bias, and the bias definitely exists in the data sets itself. whatever data sets that we are using to train on, the output is likely to be modeled on it. To give you an example, if you look at, there are a lot of roles that are more male oriented. And if we are using the same data to train our models, the output is likely to be more driven towards men and instead of being gender neutral.
And I want to get a little bit more into which companies are actually working or active right now in that generative AI space. Can you elaborate on that a little bit more too?
So we know all the usual suspects, whether it is OpenAI, Google, Facebook, Microsoft, they're all very, very active in this space. But if you look at companies like Adobe, they are doing significant amount of time and are a pioneer in the field of generative AI. Their Sensei technology is used in a variety of products like Photoshop, Illustrator, and so on. Then we have Hugging Faces. It provides open source tools and resources for generative AI. Their Transformer library is one of the most popular out there for generative AI. We have Autodesk that is using generative AI to automate tasks in the design and engineering process. For example, Autodesk's generative design technology uses generative AI to automatically generate a variety of options on a given set of criteria. There are many other companies like Uber, Salesforce that are using AI or generative AI to improve their services and operations. Companies like Expedia, Kayak, OpenTable, all these companies have trained large language models to improve upon the customer experience and remove friction in the customer journeys. Having said that, it's not that generative AI is limited to big companies alone. Gates Foundation is funding 50 projects in middle and lower income countries. And some of the projects are very fascinating. One of the examples, and that really touched me, was a group of scientists in Uganda. They plan to build a chat GPT based application to provide information to farmers on crop diseases, and that too in their own native language. Imagine how powerful that would be. The problem so far has been that a lot of knowledge has been there, but not available in the native language, and hence the lower strata or the people who do not know the other languages have not been able to benefit from it. Another project in Brazil, there an NGO is planning to use these large language models to develop a support bot for psychologists and lawyers, helping women to who have faced gender-based violence. Akshara has been doing a lot of work on researching the generative AI ecosystem, and she can talk more about it.
Yeah, thanks, Mohit. So I think you very beautifully explained how the companies are using the models. But if I just take a step back, so if I go from the stack, who are actually creating those models? So we have the obvious, as you said, the obvious companies, the big techs, which is Google, Meta, Microsoft through its acquisition of stake in OpenAI. But then we have also other companies which are working on that, whether they be the Chinese companies or other companies which are specifically in Europe. There are a lot of companies that are working on also creating their own models. For example, in China, it's about Beijing Academy of Artificial Intelligence. Then we have Alibaba, we have Baidu opening up. In Europe, we have actually Eleuther AI, Lion, and Bloom. Which is the parent company, or the parent company is Big Sign. So it's a non-profit sort of company which is working upon AI, creating models. So these are the companies which are actually creating that infrastructure, basically those AI models, and the other companies either are licensing from them or are using it through the open API sources. And then if I go back the stack down the stack again, where are all these models trained? As we mentioned earlier in our podcast, that they require large amount of computing resources. So where is that compute sourcing coming from? Who's providing the infrastructure? So the companies have two obvious choices: either they buy their own infrastructure, the IT data center infrastructure, or they go to cloud companies. So Meta, AWS, Oracle, Alibaba, Microsoft, Google, Cerebras, Baidu are kind of the top cloud service providers which are giving AI as a service or supercomputing as a service, depending upon the company's requirements. And the most kind of right now, the most hot topic in the specifically on the hardware side of things, if I come, who's providing that infrastructure itself. So NVIDIA is the current darling, considering they actually have almost monopoly on the AI chips. So AI chips require specific type of chips because there is a lot of compute happening parallelly, so the models can train themselves. So NVIDIA is the highest, but the traditional chip companies like AMD and Intel are also catching up with their AI offerings or AI specific or focused offerings. And then we have companies like Broadcom and Marvell, which are making the AI chips on behalf of certain vendors, whether it be Google, Amazon, or Microsoft, which means they do a custom silicon chips. And then, so pretty much all of this is coming from the hardware angle. And then if I just again step a bit more back and see who's manufacturing that hardware, then it is primarily TSMC, where most of these chips are right now being fabbed. Intel is, of course, using its in house foundry, but rest everything is actually being fabbed on TSMC right now. So this is kind of the whole ecosystem that we have talked about, from software providers or the application providers to hardware and manufacturing.
Awesome. That's a lot that you just unpacked there. But I wanted to more specifically focus on one thing because you mentioned a lot of US companies actually that are in that space and only a few Chinese companies. But I wanted to, for you to just dial in a little bit more on what specifically the Chinese companies are doing in this space.
Sure. So Chinese companies, due to the ecosystem or the unique ecosystem that China has, what they are trying to do is each company is trying to build their own AI model instead of a hybrid mix that we have seen in US and Europe, where the where the companies are either licensing the AI models, for example GPT 3.5 or 4.0, for their purposes and integrating it out. So for example, like we mentioned, Adobe, Salesforce, most of them have integrated GPT. But Chinese companies, each of those major Chinese, either an e-commerce player or a cloud player, have built their own proprietary AI models. That's like a kind of a different take to what Chinese companies have taken. And secondly, there is another, what do I say, perspective coming from a macro point of view, where the companies, due to the bans of the chip companies, for the chips specifically by US government, so they are facing a lot of obstacles actually sourcing those chips, and consequently the hardware that can train their AI systems. So I think that will be a bit of challenging kind of headwinds for the Chinese companies, but it's definitely, the ecosystem is definitely kind of building up in China and US both.
Those are some great insights, Akshara. But I wanted to ask another question to Mohit now. So generative AI has a lot of powerful features available right now, right? So it's extremely useful for a lot of different use cases, as we've been discussing. But as I'd like to quote a little thing from Marvel, from Spider-Man, actually, with great power comes great responsibility. And now, what are some of those challenges associated with this accelerated process we're seeing from AI?
Thanks, Maurice. It's a great question. Generative AI is still a new field and there are many challenges in it. The top two challenges are high cost and potential for bias. Bias is something that I alluded to in your previous question as well. And then there are many other smaller challenges that are there, which we will need to address over a period of time. So generative AI models, they require a large amount of data to train. And this can be a challenge for businesses that do not have access to large data sets. So again, there could be a digital divide that can come in between the large companies and the smaller companies, just because the smaller companies may not have enough data to train on. Then the other challenge is the training complexity is really high. So for training the generative AI models, we really need a very high compute power, and these are time consuming. And also depends on the number of parameters that we require to train. So as the number of parameters go up, there is an exponential increase in the computational resources and the training times that we need. We already spoke about the challenge of bias. So, if you look at training data sets, and if the training data sets itself has a bias, then the output is likely to be biased. To give you another example, if the model has been trained on a lot of images that have white people in them, then most likely the generated images will also have white people. There could be cultural and gender biases as well. The other challenge that is there is the intellectual property right itself. So these generative AI models, they are creating new content such as images, videos, and music. We need to have clear laws and need to develop clear intellectual property rights for generative AI models, because the creators of the images or the content that was there, they need to be compensated, because the base for the generative AI output is the content from the creators themselves. So how do we compensate them is something that we really need to find a way for forward on. Then there are issues around deepfakes and inaccurate responses with confidence. There are issues around cultural sensitivity also. So I used Chat GPT multiple times, and I'm surprised the kind of answers that it gives me with confidence. And sometimes it's giving me the wrong answers, but with such confidence that I tend to believe that what I know is wrong, and what it is telling me is probably right. So we need to have a way of finding out how to find the responses that are accurate, and some of them which are not accurate. And then there are other challenges around AI specific infrastructure that needs to be developed for training these AI models. And within the companies itself, we will need to have the culture and the organization to support it.
Yeah, and just to your point of you getting confused using some of these generative AI features, you know, we're not going to lose our jobs, I don't think, anytime soon. Someone needs to definitely still take a look at what's being produced, and a human needs to go through that data to make sure everything's correct, because a lot of times there is still something going on there that we need to definitely look at. But again, you mentioned infrastructure, and I think AI infrastructure is actually a really key point in this. Akshara, can you tell us more a little bit about the current hardware that is being used for AI advancements?
Like in my earlier description, did talk about the ecosystem of AI, what are the companies doing, who are the major players. But all at the end of the day, it comes to is no matter what the company's ambitions are about their AI, whether they want to integrate it across their whole suite of services and offerings, or maybe just a company wants to bring out a specific cool AI kind of an add-on feature, or maybe a new feature which the consumers can try or enterprises can try. But this all can happen if an AI model exists in the first place. So that's where this AI infrastructure kind of is very crucial. And what we have seen this year is, and probably it will kind of spill to the next year also, is most of the companies who actually invest in AI IT infrastructure to have transitioned their investments in AI vis-a-vis the general purpose compute that we have seen in past years. So whether I talk about Amazon, whether I talk about Azure or Microsoft, Google, Meta, we talked about Alibaba, and we talked about Oracle. So any company you take it. So what we have seen, like we just ended the Q2 earnings season, as it is like fondly called. So what the common thread across every company was the investments in their AI infrastructure. And so where it stems is right now the hardware infrastructures, it all comes to compute, and the compute is in scarcity right now, because as I said, Nvidia is at the top. It's pretty much the company which is making off shelf chips. AMD, Intel, Marvel are catching up, but still they don't have a feature which can compete with the NVIDIA's top of the line or the latest product portfolio. And in fact, we just like I think we are hearing that Nvidia is sold out till end of next year also. That's the scarcity of AI chips that is going on in the market right now. So I think this companies who are building out AI infrastructure would be super crucial. And the second thing we would see also is the new business models that are coming up. So we are seeing a lot of companies, as I said, they are either offering AI as a service or supercomputing as a service or even GPU as a service. For example, we have seen there is a new, not new, sorry, but a very specific niche cloud player, which is only a company called CoreWeave, which is just giving GPU as a service. That's it, nothing more, nothing less. So I think the companies are also having a bit of trouble finding right AI infrastructure at right cost that they can they can train or make their own proprietary AI models and then use it to either create a consumer facing app or an enterprise facing app. So I think this will kind of continue. And the second constraint is coming from the production also. So why NVIDIA can't, produce more and more chips, because it's coming from at the foundry level, which is TSMC, because AI chips need a specific level of packaging, which is CoWoS. So, and that right now capacity is not as at scale as NVIDIA would like to or TSMC would like to. And then the other component, specifically memory, they use HBM memory, which is high bandwidth memory. And also right now there are very very limited suppliers which are providing HBM, and the AI chips, HBM is a necessary component for these chips. So right now that is also in scarcity. So I think these all kind of ecosystem challenges and constraints are causing not the AI infrastructure to scale as per the demand is there in the market right now.
That's an excellent recap, I think, of what's happening right now in that ecosystem. And Mohit, if you could add on to this a little bit. Akshara mentioned a little bit on this already, but can you expand on what chipset players are actively doing right now?
So, as Akshara already mentioned, that NVIDIA has a head start, as most of the focus right now has been on the compute layer of generative AI. However, there are many other chipset players that have announced their intention to integrate AI within their chipsets that are intended for different applications. So, there are companies like Celebras, Esperanto, Tenstorrent, Graphcore, Samba Nova, AMD, and Intel that are focusing on AI hardware. Each of these companies are trying to solve the challenge of ever growing AI models in their own unique way. So, Cerebras, for example, it's a company that is known for helping with COVID-19 research, is on a commercial expansion that would pit its hardware against the compute infrastructure built on NVIDIA's GPU. And the other thing that we have to keep in mind is that not every chip requires 180 billion parameter model to run. Scaled down AI models work very well, and this has been demonstrated by roadmaps of chipset companies like Qualcomm and MediaTek. The other thing that we have to do is make a distinction between AI training and AI inferencing. AI training is where a set of data is fed into a model and it learns from the data set to become more capable of making predictions. While AI inferencing is where the application uses what AI has learned during training. The compute requirement for AI inferencing is much lower than that for AI training. Another big opportunity is for AI at the edge, where computation is done on the devices where the data is generated instead of taking the data to the data centers to run AI models. An example is autonomous cars, where latency is critical. Many chipset players are addressing or working on addressing the needs of AI at the edge. So AI at the edge is a huge opportunity in itself. And as AI becomes more prevalent, real-time AI insights will happen at the edge for many use cases.
Really fascinating. Thank you, Mohit. Now, before we wrap up the podcast, I had one last question I wanted to ask Akshara. Um, Now, I wanted to ask you a little bit more about what's happening in the future. So, can you tell us a little bit more about how the ecosystem will continue to evolve?
Sure. I think in future, firstly, the companies would start, at least would kind of mature into the AI infrastructure, or they would have, training models which are either on an iterative basis, they are like training constantly and, are kind of updating themselves. That's where I see like the future of AI model going on in. But as Mohit mentioned, inferencing will also become lot crucial, because once the models are trained, they need to bring out the outputs which are very contextual for the user and super smart in terms of either it's whether it's new content creation, or no, even giving out answers which are contextual in nature. They understand my context. And that's where I see like the companies who specifically focus on user consumer health devices will kind of ramp up, because inferencing will happen at where the consumer is sitting or where the end user is sitting. So that's where I see a big play, the companies who make user devices, and of course the infrastructure for the UI user devices, whether it be Qualcomm, MediaTek, and the devices like like those vision glasses or the AR glasses that we see, or whether it's my smartphone. It will truly become from a just like a predictive maintenance sort of stuff, or a predictive answering to a actually a smart assistant for me. It will truly become a very customized thing. And I think most of these companies who are at the forefront where they make the consumer infrastructure have already demonstrated in their either the roadmaps or with the POCs for their products and chipsets, that how they are going to integrate AI and hence make AI actually prevalent across the consumer, because they can't always go back to cloud and wait for internet connectivity or any kind of connectivity for that matter to give an answer. So the future is, maybe you're not connected to the internet, but still your smartphone is working smartly. I mean, that's where I actually envision the future. And as we call it in our tech terms, it is edge. It's everything lies at the edge. So I think edge computing, and specifically edge AI compute, will become more important, specifically once the companies have built out their back-end AI infrastructure. So I think more of this probably later next year, 2024, second half, we would see lot of announcements and devices coming on which cater to specifics of these devices and use cases.
Yeah, that's actually very interesting because you and Mohit both talked about this topic of AI at the edge and edge computing and how that's all really evolving. But however, for the sake of time, I think we need to save that for another podcast. So I think we'll end it here. Thank you, Mohit and Akshara, for joining the podcast and sharing these really great insights.
Thanks, Maurice, for having me. Bye.
Thanks, Maurice, for having me. It was a pleasure talking to you.
Thank you. And for our listeners, thank you for tuning in. If you have any questions or wish to chat with our analyst on generative AI or any other topic, please do reach out at press@counterpointresearch.com. You can also listen to our previous podcast on your favorite podcasting platforms such as Spotify, Apple Podcasts, Google Podcasts, and others. You can also follow us and subscribe on our YouTube channel, Counterpoint Research, for analyst takes and other coverage. And that's it for now. I'm signing off and see you on the next one. Take care.